Hello, this is question 2 on your June 2022 AES level paper from Edexcel. You have to use the factor theorem to show that x plus 3 is factor of this function. Remember, the factor theorem says that if x plus 3 is a factor, f of minus 3 must be 0. So we just have to check what is f minus 3. So we have 2 times minus 3 cubed, just substituting, plus 5 minus 3 squared plus 2 minus 3 plus 15. And when you do that, you can use the calculator, it's 0. Yeah? Therefore, x plus 3 is a factor. Then B, it says find the constant a, b, and c, such as fx, this function can be written as x plus 3 and another polynomial. When we divide this function, which is the degree is 3, by x plus 3, we are going to get one function that is degree 2, a quadratic, that is precisely this one. So what we are going to do is divide this polynomial by this one. So just dividing polynomial. Remember, we can write x plus 3 outside and divide. So I have 2x cubed plus 5x squared plus 2x plus 15, and just divide. So 2x cubed divided by x is 2x squared. I multiply and I have 2x cubed plus 15, plus 6x squared. I subtract, and I have these two are cancelled, and then I have minus 1x squared. Minus 1x squared divided by x is minus x. I multiply, and I have minus x squared minus 3x. Subtract. These two are cancelled, and then I have 2 minus 3 is 5x. Divide again, so plus 5. Multiply 5x plus 15. Subtract, and I have 0. Yeah, so this is gone and this is gone. That means that I can write my function, my fx, as x plus 3 times this quadratic that I have as result when I divide. Yeah, so this is the expression that I needed to find. And they asked me to find the constants a, b, and c. I know it's clear which one is a, b, and c, but I would write anyway. So a is 2, b is minus 1, and c is 5. Always write a line, it takes 2 seconds. Hence, show that fx equals 0 has only one real root. We know that function has one root, which is minus 3. So they are telling us that that's the only root, which means this quadratic here has no solutions. And the way of checking that is using the discriminant. So we need to see, or we need to show that this has no real solutions. I'm going to use the discriminant. Do you remember the discriminant is what you have inside the quadratic formula? So b squared is minus 1 squared, minus 4 times 5 times 2. This is minus 39, is smaller than 0, which means my quadratic has no real solutions. Yeah, so no real solutions. Then the last bit says, write down the real root of the equation fx minus 5 equals 0. So we know the root of fx equals 0. So we know, I can do here. We know f minus 3 is 0. So fx has a root in the minus 3. Yeah? But they are asking us fx minus 5. You know fx minus 5 is a horizontal translation to the right. So my whole cubic is going to move to the right 5. So if my root is in the minus 3, now it's going to be 5 to the right, which is 2. So that means that fx minus 5 has root in x equals 2. Yeah, and I don't need to give coordinates. They're just asking me the real root, not the coordinates of the axis, of the point that cuts the axis. Yeah. So this is how we can think about fx minus 5 is the same function, just translated 5 to the right. So my root has to be translated 5 to the right. Yeah, and that's all.